You mentioned not having COVID. Is that 100% or is that probability? Just wondering for the speaker going after you. One thing both of you guys mentioned was when you do make those changes and you end up with, you reduce your pressure drop and you end up over pressurizing your demand side. Yeah, artificial demand and leaks, sure. But what about, not saying it ever happens, but what happens when you don't have regulated flow? You've over pressurized your processes as well. No worries. So I made a joke about being 26, and the problem is that I'm not. And I realized I didn't have my glasses, and that's how I had to run out, because I'm like, I'll never be able to do this. So
when you're in your 50s, you keep one all the time.
That's right. That's right. So really hope you guys have been enjoying the track so far. I was really excited to work with all three of these guys. I've worked with Tim before, never with Mr. Mustafa, never with Mr. Scott, but as we've been reviewing and working on these slide decks together, you could really sense the passion in the room, and it was really exciting to be a part of the team. So I'm just super humbled and thankful to have been able to work with you guys on this. So I'm going to be talking about designing compressed air distribution like an electrical grid. Since transparency matters, I'm going to have 22 slides. 6 of them are going to have electrical references on them, and 10 of them are going to have pop culture references from the 80s and 90s, which I don't understand because I'm only 26. But so my name is Josh Wamser. I started adulthood as a young infantry Marine. So when they say always be the smartest in the room, that's not me. It's not going to be me. I've been known to keep some crayons in my pocket. After the Marine Corps, I went into the Navy's nuclear propulsion program and was a submarine operator on a Los Angeles class submarine before getting into the compressed air industry. I am an industrial general contractor, a mechanical contractor, a project manager, and I'm also a proud owner of Industrial Compressor Solutions, a compressor distributor, Tamsan-USA Compressors, a huge compressor manufacturer that sold almost 75 compressors nationwide, and Luftman Contractors. Well, come on, Joshy. Electrical systems are designed with thresholds from the circuit all the way back to the power plant. We size electrical circuits for their rated amperage plus a buffer. And that's where our first trip point is. Selective tripping is a concept where we design a trip point at each point of the circuit to trip the smallest part of the plant as possible. We would like to trip as close to the load as possible. I'm gonna get used to this thing. Hopefully, not shutting down the greater Atlanta area, right? But compressed air systems are not designed like electrical systems. And today we're going to talk about that. What we're going to be discussing is compressed air distribution networks from the point of construction to where they are today, and ways to optimize your distribution network for maximum reliability. Distribution networks are designed to efficiently deliver compressed air from the source to the process. But they are more than that. The distribution network affects plant reliability. If the compressed air system goes down, so does the plant. But it's more than just go, no go. Because compressed air, like my colleagues have been saying this morning, is a process variable. Quality, pressure, temperature, and flow, nice to see, that's the Marine in me, yeah, all have the ability to affect product delivery, quality, rework, warranty, and scrap. This week you've heard a bunch on the effects of air quality and temperature from different speakers. In my presentation, I'm mostly going to be talking about pressure and flow. But that being said, if your compressed air system is not reliable, then neither is your manufacturing process. I heard a speaker yesterday. I don't know if he's in the room, Mr. Paul, and I was stopped in the middle of his presentation. He said, we cannot, when we are in the plants and facilities of our customers, we cannot make our customers feel stupid. And, you know, I felt like the rest of the presentation go away. And, you know, when we talk about from construction all the way to our operating plants, it's easy. And, you know, Mr. Tim, you talked about it a little bit earlier, like, right? We design a system and then somebody touches it, affects it. Mr. Mustafa talked about valves, you know, and adjusting valves and, you know, as a reactive measure. But one thing I have learned is that 90% of everybody is just doing the best they can. And that is everyone, starting at the architects, all the way through to the plant personnel. We are all doing the best we can. We're trying to learn from each other. We're trying to be the best we can for, you know, our families, for our children. And so we, what did Mr. Paul say? Amnesty. He said one word, amnesty. And I really thought that was incredible. And that's going to be one of my key takeaways for this event. But all that being said, there is no perfect plan. It just doesn't happen. So how did we get here? How do we get to the point where your sales engineers get called out? How do we get to the point that Mr. Scott gets called, Mr. Tim gets called, Mr. Tom? It's more than a function of time, right? But changes in production, leaks, wearing equipment, equipment failures, pressure control, all of these things are compounding over time. A lot of times when we get the phone call, there's a problem on the production side, whether it be with quality, whether it be with inadequate pressure, not getting the flow rates. I've seen production managers where they are shutting down portions of their plant or operating pieces and parts of their plant like a conductor to try to keep the system going, right? Our compressor room, when our compressor room cannot provide the volume and pressure that our processors require, what do? Yeah, we need more compressor, right? That's what the amp clamp said, right? Right? You send a young sales engineer in. Oh, and this, ladies and gentlemen, is Mr. Paul, the gentleman that gave me the word amnesty, and yeah, really helped set me straight 2 slides ago. But when we talk about that point in the world, the point in time when we get called in for inadequate pressure or improper quality or whatever, right? A lot of us have been taught, especially as we first get into the industry, to do that quick snapshot audit that happens to be with equipment from a manufacturer, that happens to say, you need a really big VSD compressor, right? I had a customer it wasn't actually my customer at the time. They had two 25-year-old 100 horsepower compressors with it was full backup. Plant operated inside one of them, second compressor, 100% backup. That customer lost an errand on one of the compressors and immediately called their service provider in to see what to do. They had amp loggers on that compressor the same day. I think the salesperson had them in his pocket. And 10 days later, had a quote for two 150 horsepower variable speed drive compressors. So they had 100% backup and, growth that, I don't know where that growth profile came from, but, there you go. I actually only got the call to be a second quote. They didn't want my opinion whatsoever. And I said, well, can you at least show me the data that got us here? If I am going to quote these 150 horsepower compressors, I'm going to be responsible for them. So I would like to see, where these calculations came from and what we're going to see from there. And I think that was the point, and that is what started our relationship on the correct foot there. We need to change the way that we're looking at these plants and facilities. The first thing that I wanted to do in that scenario was make his plant reliable. The customer had lost that 100 horsepower compressor. His other compressor still ran the plant perfectly, but in that moment, he was gambling all of his production. He was gambling the labor of his employees. Everything was being gambled on a 25-year-old 100 horsepower compressor, and if it worked. So his decision-making wasn't really, in his own best interest long-term. So the first thing we did is we installed a rental unit, and by installing a rental unit, now we can have real discussions. I installed a flow meter permanently at the discharge of the dry receiver tank, and we started evaluating for peak and average demand. We evaluated waste on the plant side. We determined reasonable operating conditions with the customer and with the production team. I love that you said that. And then we determined the range of air demand that needed to be available efficiently. And then we designed the compressor room. And I stop here, love Ross Geller. The best we can do in our compressor room is react to plant demand and all of its waste. So let's think about electrical again. Picture the overloads tripping on a circuit. We have a choice in that moment. We could grab a Phillips head, we could grab a pocket knife, we could make a small adjustment to those overloads and get back to work. But if we bypass those overloads, go back to the selective tripping concept, if we bypass those overloads, we are putting a larger portion of our plant at risk. What we're supposed to do in that scenario is troubleshoot and repair and find out why those overloads tripped. Because those overloads successfully told us that our current threshold had been exceeded. Successfully told us it was time for maintenance, and successfully kept our electrical system within its limits. Our compressed air distribution network also needs thresholds, indications, and maintenance. But when do we do it? And if anybody's seen that movie, I know you can hear Jim Carrey saying that, right? And I'm not even mature enough to get through my own slide deck. Yeah. But there's a very real question here. When do we need maintenance? As a production manager or a plant owner, you cannot simply shut down production every time somebody finds a leak. We need to figure out a viable way and a viable time to know when to do this. So we need a threshold. When our compressor room can't provide the volume and pressure that our processes require, it's already too late. In a lot of plants, the threshold line and the alarm line are the same line. And what I'm saying is, we don't get a call until 75 people are walking around sweeping with brooms trying not to get sent home for the day. But in that time, it's already too late. So one of the things that we can do is isolate that threshold from the alarm line. And a fixed place that we can put that is before our backup compressors. When you look in large plants, you might say, wow, we've got 10 compressors running, and depending on the time of day and the day of the week, we might find that 3 compressors run sometime and 9 compressors run another time. But it does not change the fact that in the moment that we get into our backup compressor, we are gambling all of it away. And when production stops because of compressed air, we have all failed in our job. We are go, no go on this threshold line underneath our backup compressors. We are go, no go. If we start our backup compressor, we are no longer reliability. We have had a go, no go effect on our plant's reliability. But when we're underneath that line, telling how far away we are from the line is a different thing entirely. Knowing where we are in reference to our threshold line becomes our next question. Now, when we look at snapshotting actual demand, and we see that, people will do that in the compressor rooms, people will do that with flow meters, people will do that with plant audits, permanent monitoring. You can do it by compressor hours. You can do it in multiple forms and fashion. But getting that snapshot of where you're at, making adjustments to your peak demand, and moving your actual demand away from your threshold, you are increasing your reliability as you move that away. And with a properly sized supply side, like Mr. Scott was talking about, you also, and Mr. Tim, you also are afforded the opportunity to be more efficient. All 3 of these gentlemen have been talking about reductions in the demand side and then going back to the supply side and increasing efficiency, right? Set threshold, but underneath the threshold, we are more or less reliable. How do we minimize? How do we minimize our actual demand? Fixing broken and worn out components and equipment, reducing artificial demand, leak management, pressure management, optimizing the distribution network, correcting pipe sizes, adding receiver tanks, nozzles. Right? These are the things that we do to reduce our demand profile from that threshold and maximize our reliability. Like Mr. Scott said, in order to truly be able to do that, we have to be able to measure it. Having backup compressors, proper pressure, quality, proper flow, that is how we maximize our reliability. The moment we get into our backup compressor, that's when it should be too late. Adjust your threshold to the backup compressor. You make that your threshold, right? when we talk about thresholds, we're not just talking about thresholds on flow and pressure, though. We've heard talk already about quality and temperature as well, right? If our pressure dew point requirements, if our oil requirements are less than X, create a threshold there, right? Give the warning. Reliability, a go-no-go reliability is not very reliable. What we've been doing is reacting to plant demand as efficiently as possible. That's what we see when we're looking at sizing compressors, variable speed drives, automation, controls, matching one-to-one power to flow. We're reacting to whatever the plant is giving us. But if we want to maximize efficiency, we need to maximize our reliability. We need to drive plant demand down towards maximum reliability. As I said a little bit earlier, one of the things we've started doing in our local service company is we have permanent monitoring installed in the plant. And our customer is paying us every 3 months to evaluate and trend that last 3 months and walk the plant and make the repairs necessary to get that demand profile back in range of where it's supposed to be. And what we end up finding, not only are we getting paid to do that up front, right? But our solutions for efficiency and reliability have nothing to do with capital cost. So, about 10 years ago, like I said, yeah, I'm a Marine, right? Infantry Marines, we're stupid, we jump out of things, whatever. It's kind of what we do. As I started learning from a lot of the people in this room, I started getting like really motivated, like only a Marine can get, right? And I had a conversation with Rod Smith. And I was just motivated, but like I had lost control of the words coming out of my mouth. And Rod, obviously one of the kindest human beings you can ever meet in the world, right? He says, you know, the people that came before us have got us here today. So maybe we should think about, you know, disparaging the people that came before us. And, you know, that moment for me in my professional career with Rod and his rolled up newspaper smacking me on the nose, right? That has pivoted me from that moment to where we are today. And as I was creating this slide, I was thinking about that scene in Greece, like with the hydromatic, right? And that has been done, right? You've had your Roy Stolmans, you've had, you know, we've had these predecessors that have come before us and looked at unloaded part load inefficiencies. They've gone from poppet controls on errands for effective rotor length adjustment to variable speed drive, controls improvements over the years of just bang, 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 bang. These guys have worked tirelessly through their careers to get us where we are today. And I wanted to make sure, as one of my takeaways, that this is not disparaging what's gotten us to where we are today. It's not meant to do that at all. But I do think for those of us that are younger, like me being 26, that we need to take that torch. I'm not selling that very well, am I? No. Yeah. That's right. It's time for us to take that torch and take where they've gotten us and move forward. And one of the things about where we're at right now today with compressed air best practices is we have been given an open forum from all different manufacturers, from service techs to salesmen to engineers to project managers, to all come together and voice our opinions. You got to see Mr. Scott and Mr. Tim 30 minutes apart, looking at different ways to skin the same cat. And that was awesome, because we have this venue here that allows us the opportunity to do that. And that's what we're talking about here. Take that torch and move forward. I don't know what's going on there. It's a go-to meeting.
You're right on time. Very good.
Any questions?
This threshold idea of yours is really new. I like it. So in the utility world, they talk a lot about dashboards and KPIs, performance indicators. Why couldn't you put, the circuit breaker idea, okay? You get 4 major branches, let's say, or loops. You just put 4 flow meters out there. And if you preemptively knew that, okay, back here at the compressor room, your threshold was whatever, 2,000 SCFM, that's the pain point. And you know that if these guys, and you can flow limit them with the nozzle if you wish, or just because there's a randomness, you might not want to flow limit. If this one's 1,000, it's sub-threshold. It's like a circuit breaker. You're not going to shut them off, okay? But that's the threshold, right? And this one's 500, and this is 1,000. Why wouldn't you want to just trend the flow meters, have a little smarts back at the dashboard that says, hey, in the last day, you were 10% close to your threshold.
There you go.
It's not a lot of numbers. It's like you're at 90%, guys, and last week you were at 80. And then over at the compressor room, that's why you're at 84%, because it's this branch over here. It's growing.
Yes, sir.
It's just one number to manage.
That's actually one of the things we were talking about as we were building the slide deck, is how much of it changed, how much of the action items changed depending on the size of the system. For a smaller system, that you're not having to purchase anything to know, hey, I go into a backup compressor, let's do a demand side evaluation and bring us back under, right? The service technician, whether they be in-house or being facility maintenance, all they need to do is see that there's hours on the backup compressor, and that'll, give them their call to action. As you get into larger facilities, you look at flow meters going into the demand side, your small to mid-range plants, put a flow meter on that demand side and capture it that way. And then on the larger plants, Mr. Tim actually talked about the highway going out to multiple loops, multiple buildings, and process groups. Didn't use the term, but you're talking about process groups. And on your larger facilities, you can manage your air and set thresholds at the process group and process outlier level. You can do that with flow meters. You can regulate the pressure to the pressure of that process group or outlier. You can use tanks, nozzles, check valve, but you can do it by the sub loops and process groups as well. Sir.
Talking about thresholds and that type of a thing and control, one of the challenges for our industry going forward is to become a bit more like the process control industry. So in other words, we see in that data that actual demand peak that's occurring there. And so when you get all of your data pulled together, particularly flow, and you have all your FLBs, that's a technical term, funny little bumps. You got all the funny little bumps in the data, you need to say, that FLB is this piece of equipment, and make those correlations. Now that becomes a characteristic signature. I did a job at Alcoa in at Washington, smelter plant. And one of the goals of the assessment was that from time to time, they had a terrible time getting the plant started in the morning. And so we're going along, and we had a lot of those major event things hitting. And we got in a meeting about 3 days in. We had everybody there, the whole team was there. I said to the controls guy, "What's this?" And he went, "Oh, that's phase number 3 firing." I said, "What's this?" Tell right what it was. Then I showed him what happened in the morning. And I said, "What's this?" And he laughed. He just roared. He says, let me tell you, at 7:30 in the morning, the system looks at all of our day silos for material. And everyone that's not up to a certain level then tops up for the upcoming production for the day. And I said, now, is there a reason you gotta do that at 7:30 in the morning, do them all at the same time, while at the same time you're trying to get the plant running? And he went, no. 3 days later, the whole crop was stopped. They started at 2 a.m., they staggered. By 7:30, all of the silos were ready to go, and they never had another problem trying to get the plant started again after that.
And
That, in process control, that's something that they call control forwarding. And Josh said it a few times, and Scott as well, that we react in the compressor business. We wait for the demand to go like that and the pressure to go like this, and then we go, oh, we gotta do something. We need to adopt process control strategies, which is to get ahead of it, and we know the things that are gonna happen. So when a dense phase unit powers up, it doesn't just power up and go whoosh. It powers up and there's things coming on and so forth and so on, then it goes whoosh. Well, we send that signal to control and it says dense phase 3 is powering up, it's gonna go whoosh, what do? And you have a control program to anticipate what the needs are gonna be going forward. So for you guys carrying the torch, I'm just telling you from a few years of experience, some of the stuff that we need to get a little bit smarter about.
yes, sir. And I think Mr. Tim said it in the beginning of this, and I've heard it said throughout the last couple days as well. These presentations were not designed to give end-all be-all solutions for everything. They are made to trigger thought. They are made to introduce concepts, challenge the way that we've been thinking about things, and give us a point to move forward from. So, and man, again, I'm so thankful to have been a part of this group and to be allowed to speak at Compressed Air Best Practices. So thank you all very much for your time. We really appreciate it.
Thanks, John.
Yeah.